All right, I think we're ready to begin here. Did we need to go over the homework assignment, or can we just start on the meeting quiz?
I'm ready to go.
Okay,
How about you? You
I'm ready.
guys? Okay. Nidia, are you okay?
I didn't get it. Sorry.
Are you good with just going to the quiz, or you need?
Oh no, it's okay. Just the quiz. Thank you.
Okay.
Okay, cool. And I think most of us we do the quiz before. Do you guys do the quiz before we come?
Yeah.
Okay,
I
cool.
started doing it before. Yeah.
Okay, cool.
Oh, I couldn't do that.
Okay, so I'll take the first one.
All right.
Okay, and then what are we going?
Thank you.
Gabrielle, then Lydia.
I can go 2 or 4. Yeah, 4.
Okay.
Okay.
Okay, so the true linear regression equation is, and I forget what these are called, but it's the y equals the
Yeah, me too.
the b the b0 b1, and they have names, but
Yeah, they do.
where both of them are unknown. What are the null hypothesis for b1? Is that it's not Bravo, is it? I can't remember.
Beta. It was
Beta.
beta.
That's
Yeah,
right.
okay, there you go. There you go. She's good.
All right. Okay, and so the null hypothesis is that it is
Yes.
0, and the alternative is that it is not 0.
Okay, I agree.
So the residual is the number 3, is the difference between the observed value y and the value predicted by the regression line.
Okay. I was trying to... Okay. Says a plot of residual supports using linear regression when let me just it's constant. The first one, the residuals looks normally distributed,
Yes.
but I'm not sure.
Yes.
Okay. Okay, thank you.
Okay, and then for this one, I can put this down. Probably easier if we do this. Oh, we need the Excel. So for this one, compute the residuals for the data using software. What statement best describes the residuals? And so I took the math scores here. I went to this the linear regression tab here, and I put the confidence score here in column A, and the response variable here, how they did on the test. In this column, ended up with my residuals. And then I took the residuals, I copied all of this, because I don't think it's actually on this spreadsheet. So then I just come over here to this one, and then you can put them in here. And then I sorted A to Z so they're in order, and they are definitely on the in line there.
Yeah.
So, but the other thing, and that helps us on the other one, but what it also tells us is when we look at the data there, you can start all the way at the top, and it's 38 is minus 38 is the smallest one, and the largest one was 23. So that tells me that they are all between minus 40 and 25.
Mm-hmm. Yep. Okay. So in the next one, since we already saw the Kiko plot, the residuals is number 2, which is fairly normal.
I agree. Here, use software to create a scatter plot of the data given the scatter plot, residuals plots, and the QQ plot. Which of the 5 assumptions about linear regression are satisfied by this data? Check all that apply. Okay, the first one, there is a linear relationship between X and Y. The third one, the residuals are normally distributed.
Yeah.
There's one more.
Yeah.
One more. Okay. Oh, the observations are independent? No,
Well,
not right.
we can't tell that from what we looked at.
Yes.
And this one here, if you think about it, how do we know that all of this was without error? We
Right.
have to trust the person that's giving the, that gave us the data.
Oh. So it would be
Couldn't be that.
the fourth one. The X values are measured without error.
No, that one we don't know.
No, we don't know.
Oh,
By just
okay.
looking at this data, we have no idea if they did it
Yes,
right or not.
I got it. Thank you. So it would be the second one.
Yeah.
Okay. Okay. Thank you.
And really, where the variance of error terms, it goes to the variance, if I understand correctly. So how we knew that, just FYI, Nydia, is when we looked at that Q plot. Where the heck did it go?
Okay.
Hold on. Did I have it here? Where did I put it? Anyways, when we put the variances in, there was a Q plot, and it was just a straight line like this, straight as can be. So those, that right there is what told us that the variance of the errors were constant.
Right.
Okay. Thank you very much. Okay.
Okay, so it's back to me. So what is the estimate for the slope? And so that's the 12.69 slope right there, 12.695.
Okay.
All right. And then what is the lower bound? And is the 10.674.
Okay. And the upper bound would be 14.715.
Okay. And then it says, based on the evidence and using level of significance of 0.05 or 5%, what decision would you make regarding the hypothesis test for B1? We would reject the null hypothesis test because the p-value is less than 0.05. The p-values are really low.
Okay.
All right. Next is for a hypothesis test for B1 slope. If you reject the null hypothesis, what does it mean? And is the last one, there is sufficient evidence sufficient to include that the slope of the regression line is not zero.
Okay. The next one says, now we have to use a Tarin crocodile modified Excel sheet to see the headline if was used to predict body length. For this data, which variable is the dependent variable? Okay, let me check this. Mhm. Dependent variable. Oh. What is that? I
So
forgot.
if you'll remember, the dependent variable is also the response variable.
Oh, so it would
So
be.
here's
Can
your
you?
clue of what it is. It says here, predict the body length.
Oh, it would be the body length.
Yeah.
It's the body length. Yeah. So what you can remember on this one, remember there was kind of the case study they used that they had found crocodile heads and they used the crocodile heads to predict the body length, right?
Yes.
And so the dependent is to get the body lengths, you're dependent upon knowing what the head length was.
Mhm.
Okay. Thank you. Thank you.
I think, let's see if I can get this to copy over. Get rid of that one. And we want the head length here. It happens to be in the right order, so we can just copy it over. Oh, no. Okay, put it down there. So now that our data is in there, we're trying to find the information that goes off of the slope here. And so our margin of error, we're going to take the confidence interval, the higher one, subtract the lower one, and then divide by 2. So we have the 8.103 minus the 7.218 divided by 2. It's 0.443.
Okay.
This is now input the lower bound, and I put that it was 7. Else.
Are you using Excel or are you using
I use my
the software?
calculator this time.
Okay. Well, I think either one works, 7
Yeah.
or 7.218.
Well, I got it right, so must
Yeah,
have
and I
done
did 7.218 and it got it right. So either one will work.
Okay.
Okay.
And then the upper bound would be 8.103.
Correct. Did you use something else there, Gabriella?
Yeah.
Okay. But that will work.
Mhm.
All right. Is it down to me again?
Yes.
Based on your lower bound and upper bound for the last two problems, Ken, what can you say about beta 1? And it's we are 95% confident that the confidence interval will contain the true value.
Okay.
Okay, we're all good.
Hey, good job, everyone.
Thank you, Gil. Thank you very much.
Oh, well, I hope your all your weeks are better. Oops, excuse me.
No problem.
I will
I think
meet you